We're going to be looking at designing MEP systems and co-compliance in the Middle East, covering the GCC region. We are really fortunate in having two excellent speakers, two practicing engineers, ChewPieng Ryan and Kathy Elliott-Scott, who work in the Middle East for Bureau Happold. They were considering how MEP services are designed to meet the needs of the extreme climate and to meet the codes and standards of those countries. Our first speaker will be ChewPieng Ryan, and ChewPieng is Bureau Happold Engineering's MEP Group and Discipline Director for the Middle East. Her passion for integrated design has led to her working on many iconic projects across the globe, which include integrated design, tall buildings, healthcare campuses, education, retail and commercial buildings. She is actually current Vice Chair of a CIBSE UAE committee. ChewPieng followed directly by our second speaker this afternoon, and that's Kathy Elliott-Scott. Kathy's an associate with Bureau Happold Engineering, again based in the Middle East, worked on a wide variety of projects around the world and been involved with sustainability assessments, including BREEAM, LEED, QSAS, Estidama rating systems. She's qualified Estidama PQP and provided technical expert support for production of the Estidama guidance. So without further ado, I'll pass across to ChewPieng.
Thank you, Tim. To start with, the topic is we're going to talk today about the building services challenges in the GCC and the interaction of professional codes and standards. To start with, building services is commonly referred to in this part of the world as MEP, mechanical, electrical, and plumbing. And our presentation here on will often refer to this terminology. So we hope today to cover in our presentation, key challenges that for the MEP systems here in the GCC, the addressing of the extreme climates that we face here, design codes that we work to here with the huge international and multinational conglomerates that we work with amongst us, sustainability and the movement towards the establishing codes in this region, opportunities for the technology, and CIBSE and ASHRAE's movements here in the Middle East. To start with, we often refer to the GCC, which is the Gulf Cooperation Council, which consists of Bahrain, Kuwait, Kingdom of Saudi Arabia, Oman, Qatar, and the United Arab Emirates. The GCC economies have in recent years embarked upon ambitious expansion and diversification plan involving huge government spending across their industrial, energy, and infrastructure sectors, alongside building up their social infrastructure such as affordable housing, education, healthcare, and sanitation, so as to upgrade the standards of living of its masses while achieving sustainable economic growth across a varied base of basic and heavy industries. The GCC countries are therefore one of the largest environmentally challenged areas due to their large-scale expansion programs. The biggest challenge faced here is always aimed at the extreme environmental conditions that is faced here. There are different systems for classifying climate, and the Köppen guidance system in the image here is the most widely used. The rapid development of countries around the world has required building services engineers to apply their specialist knowledge to areas with extreme climatic conditions and changing social patterns and technologies. In working over here, we as designers need to carry out our own detailed research. Although data provided by CIBSE and ASHRAE are adequate for preliminary works, often we have to do our own detailed meteorological research. The challenges we face here in terms of the extreme climate are early morning fog, very heavy fog across the cities, which brings upon sort of like heavy condensation when air conditioning system starts early, first thing in the morning. We get flash floods here due to heavy rainfall, which are very, very infrequent because this is a desert condition. But when it does, the drainage systems here are not usually designed to cope with such infrequent heavy downfall. We have sandstorms here, which affects our ventilation design with spatial consideration for provision of sand trap louvers. And on the last image, you'll see that we face extreme heat, as you can imagine. the temperature in the image shows you that, you know, external temperatures reaches up to 55 degrees C. This happens for almost about 2 weeks over the summer period. Further on, in the development and the huge stock of tall buildings, lightning protection has been a huge consideration, because lightning protection attracted very highly to tall buildings. It's useful to note that radioactive air terminals are often sought solution. However, we face challenges of the system not being recognized in NFPA and BSEN codes. The challenge of the dust and humidity in the conditions in this region causes big sand effect and creates challenges with efficiencies when we try to design solar PV for harnessing energy. Another issue here that we design to is seismic conditions. And when we design systems and MEP systems, we have to consider spatial consideration for movement, detailed specification for the hanging and the installation and the seismic activities that buildings have to face. And next of all, we also have huge issues with aviation warning and light pollutions in the sky, with all the competing tall buildings reaching for the skies. With all of this, how do we ask ourselves as conscious designers, how do we harness the extreme for the good of the society? Opportunities that we get with the high humidity and fog, for example, with the typical morning condensation where there's huge condensation across all of our facades, there are opportunities for dew harvesting if were designed to incorporate it. In a project that Bureau Harpo Engineering has participated in, has provided, is a project called Wadi Hanifa, which was the winner of the Aga Khan Award for Architecture in 2010. Now, Wadi Hanifa was an area which was derelict, but once a year it would face a huge amount of flooding. But with the area being scrubbed and cleaned to enhance the natural system, we created a civic space for the public to enjoy, as you can see from the image on the right-hand side. So moving on to what do we do with the design codes in the GC in this region, considering that architects, engineers, designers are all from international communities and comes from all over the world. And this area being truly the Middle East, we have designers from the West as well as the East. Due to the importance of air conditioning in this region, ASHRAE codes are used in the design rounds primarily for the ventilation and air conditioning systems. ASHRAE handbook particularly is used as primary reference for documents, providing us with meteorological and climatic data, and helps inform the basis of our design. ASHRAE standards provides further robustness in ensuring quality of testing of ventilation systems, energy benchmarking systems and materials, and the ones that are vastly used here is the ASHRAE Standards 52, ASHRAE Standard 55, 62, and ASHRAE Standard 90, widely used for the ventilation modeling in sustainability. The CIBSE codes in parallel are then widely referred to in our design world and our construction community for the commissioning codes, and we use all 7 of the commissioning codes that are listed here. And furthermore, CIBSE guides helps inform the designers in the vertical transportation system in buildings using Guide D, the building control systems using Guide H, and then facilities management companies uses the Guide M for maintenance extensively. In May 2014, CIBSE published the TM04, Technical Memorandum Manual 04, for buildings for extreme environments. This document was written with the assistance of a large community of engineers working in the Middle East and in the UAE, and talks through key issues like building envelope, daylight and solar gain, building orientation, intelligent facade design, wind movement, urban heat island effect, and U values. The manual has been is an excellent tool for reference. It covers the general design philosophy for arid environments. It provides us with, sound basis of design and talks about the consideration of geographical, local, climatic, commercial, legal, and social conditions and requirements. It runs you through the climate problems which we faced here, which I touched upon earlier. And the fundamental message about designing this part of the world and designing any systems is simplicity, and to avoid unnecessarily complicating design and detailing for this part of the world. Local resources and experience are essential to understand, and one should take full advantage of the local experience and resource expertise, and that engineers and technicians here are perfectly capable of applying tried and tested Western technologies in building services. When it comes to specialists and commissioning, it is advisable to allow for the manufacturer, the specialist engineer, or representative to supervise, set to work, and commission as necessary. And we encourage the use of package equipment that involves the minimum amount of specialist site installation work. In terms of firefighting and plumbing codes that we used over here for the public health realm, the international plumbing codes are widely used in the region alongside local municipality and utility distribution code. All countries and all regions would have their own utility distribution company. They have their own electricity and water local codes. But in terms of designing, detailed designing, we tend to use the IPC code quite extensively. And where in doubt, we would refer to the International Mechanical Code. The Middle Eastern states has, over the years, with all the tall building and the huge development, been very aware of health and safety, and in particular, and life safety, and in particular about firefighting. This is very much influenced by the region's lack of available resource, which is primarily water. Middle Eastern states base their old local codes on UK building regulations, but now majority use the US codes, for example, the NFPA 101 Life Safety Code for all our active firefighting design, and as well as the architectural life safety system. We use the NFPA 5000 Building Construction and Safety Code, and regularly refer to the International Building Code, the IBC.
Okay, so for the electrical codes that are in use in the GCC, as a very general rule of thumb, if it's a non-life safety system we're designing, we tend to look towards the British and European codes. And as ChewPieng said, if it's a life safety, the American codes seem to take prevalence, so we use NFPA. The wiring regulations across the GCC generally are based on IEC 60364, which is the 7671 in the UK, and some are loosely based even on the superseded IE 14th edition going back to 1966, coupled with local experience, opinions, and then trial and error that they've experienced in their locality. So as a summary for designing LV systems, and generally rule of thumb, you design to the local IE or to design to the IE wiring regs. You then check for local variances. So for example, in Abu Dhabi, split load boards are not permitted, and you're not allowed to use more than 14-way TPN boards. In Kuwait, you can't consider a power factor greater than 0.8 in your calculations, even if you have supplementary power factor correction equipment installed. Kuwaiti also requires additional derating factors that can significantly increase the size of your LV installation. So these are things that you need to be aware of when you're designing on top of the IE regs. The next thing to do is to check what local forms are needed for submittal and what format the information should be submitted in. So do you need to go in person to a counter with multiple hard copies? Do you need to employ a locally registered and licensed consultant to do the application on your behalf? Or is it possible to make an online application via the municipality's website? And then the final thing that you need to check is what other approvals do you need to have in place for your submittal to be accepted? So are there no objection certificates? Are there any municipality approvals, etc.? The climate has a very big impact on the electrical equipment, so anything going outside has to be dustproof to prevent the failure of switchgear, control gear and machines. And the IP coding system is what we'll use. We wouldn't go below IP53 and generally like as high as IP64, 65. Wherever possible, we try and provide local shading to protect the electrical components. The surface temperatures of luminaires, for example, can get up as high as 80 degrees in the middle of summer. And it's just so high that any shading that can be provided really benefits the longevity of the installation. Anti-condensation precautions have to be taken to ensure the continuous operation of electrical systems. There's huge problems with sand and dust and the electrical equipment. So the very, very fine wind-blown sand and dust invades devices. And what happens then is the devices fail in an energized state, but the supply remains energized. And then in a fault, CPDs can fail to function, and then there's a risk of shock and fire to building occupants. So to prevent this, you need to ensure correct specification and the regular testing and maintenance of installations and keeping installations dust-free. For specific country codes in the GCC, in Saudi Arabia, it's the Saudi Electricity Company. They have their own wiring regs based on the IEC. You'll do your design, and then the contractor does all the application and liaison with the local authority, so you don't need to get involved as much as you do in other countries. In Qatar, the authority is called Karama. They have several of their own local codes, and they have their own wiring regulations, again based on IEC, and then regular in-person discussions are necessary with Karama. In Kuwait is the Ministry of Electricity and Water. They have their own wiring regulations. As I've mentioned before, there's the additional derating factors and the 0.8 power factor that must be considered in the calculations. Other things to consider in Kuwait is that automatic transfer switches are not permitted. So for life safety supplies to firefighting lifts, this can have a big impact on the electrical infrastructure design. The lighting levels are specified in the wiring regs, so you don't refer to the IENSA or to the SLL for your lighting levels, and a local licensed consultant in Kuwait is required for the application. And the same applies in Oman, where you have to have a local licensed consultant in Oman required for your application. So what typically happens for Kuwait and Oman is you'll do all the design work, you'll engage a local consultant, and then you'll work with them to get the correct formatting of the application, and they will go and then do the application on your behalf and provide feedback to you. In Bahrain, it's very similar to the Kuwait regulations. Dubai and Abu Dhabi are a bit more developed, so they have a little bit more of an advanced system than the other GCCs. They both have their own wiring regulations. There's the DUA regs, and then there's the ADBC regs, the RSB. Both are based on the IEC. Both authorities have a green building specification or the Estidama prorating system, so sustainability considerations that will impact the LV installation design. Both have an online application method for achieving your supply to your site, and the UAE Fire and Life Safety Code needs to be followed in both of these emirates. In Dubai, the contractor will lead the process after the contract is awarded. And in Abu Dhabi, we have the Abu Dhabi Municipality Codes, the Al Ain Municipality Codes, which is the second city of Abu Dhabi. We have the Department of Municipal Affairs Codes, and we have the Abu Dhabi Civil Defence Codes. And all of these need to be considered prior, and the approvals need to be in place prior to making the online supply application. In terms of sustainability codes used in the GCC, we have CIBSE ASHRAE LEED and BREEAM, the Estidama Pro Rating System in Abu Dhabi, ASHRAE 90.2 Kuwait, the Dubai Green Building Regulations, and the Global Sustainability Assessment System, GSAS, which formerly known as QSAS, the Qatar Sustainability Assessment System.
The growth in construction in the region has been phenomenal, and this alongside huge desires in the international communities who design and construct in the region to build for the future and to a lasting quality. One thing widely recognized in practice is that sustainability needs to start at master planning stage to include designing neighborhood and communities, walkable streets, covered walkways, etc. Building benchmarking system is widely used to measure the overall performance of buildings and local systems, and has been established loosely based on the UK BREEAM and LEED system. We now have, as Kathy mentioned, Dubai has published the Green Building Code. Abu Dhabi has got the SD Dharma Pearl rating system established since they launched it in 2010. Qatar has the GSAS formerly QSAS system, and other regions often follow the US GBC LEED system, but they are entitled to have a choice of using either the SD Dharma, GSAS, or the Dubai Green Building Code if they wish. Several countries in the Middle East, such as North Africa regions, such as Saudi Arabia, Kuwait, Jordan, and Sudan, has also shown keen interest in the adoption of GSAS as a unified green building code for the region. So that kind of work is in hand.
Okay, and thinking specifically about Abu Dhabi with the Estidama Pearl rating system, and it's based on ASHRAE 90.1 and 62.1. In Abu Dhabi Emirate now, it's mandatory for all new buildings to achieve a 1 Pearl minimum rating, and all government buildings or government-funded buildings to achieve 2 Pearl rating system. We have basic commissioning credits, which is a mandatory credit. We have a U-value calculator. All Estidama Pearl qualified professionals need to be certified, so they have to pass an exam, and the commissioning agent provides professional qualification for members, so it ensures a quality of courses. We also have a prerequisite credit called ORIOR2, which is to do with energy monitoring and reporting, and this refers to CIBSE TM39 from 2009, which is a building energy metering system. Estidama has 4 rating systems. We have the Pearl Community Rating System, we have the Pearl Building System, the Pearl Villa System for smaller developments like local homes, and we also have the Pearl Operational System. So when you're having your design rating and then you'll have your construction rating, you won't achieve your operational rating until the building has been operational and inspected by the Urban Planning Council in Abu Dhabi. In terms of the cost of implementing Estidama and Pearl systems, some cost analysis was done by David Langdon back in 2010 at the outset of Estidama, and it was found that by adopting sort of passive measures in the outset of the design process, like reducing the amount of glazing, reducing internal materials, and reducing landscape, for very little capital cost, you got a very big credit return. So there was no major cost impact to achieving the 1 Pearl minimum requirement. And there's the easy win credits. So using energy efficient sanitary ware, using air-cooled chillers, and doing a life cycle costing. Again, a very low capital cost for the client, but it gained a lot of credits in return. And sort of going further up, then we have automatic controls, use of recycled materials, and increased U values, a bit more cost and not so many credits back. And at the very other end, the high cost items such as grey water recovery, use of photovoltaics, and habitat creation off-site, a large capital cost for very few credits in return.
The US GBC LEED system is widely applied to buildings alongside local code compliance, as I had mentioned earlier on. International community provides large expertise in the region. And depending on the client, the architect's influence, and sometimes even brand guidelines, they may prescribe accreditation in both local system as well as a LEED, as following the LEED certification. For example, here in Dubai, we have the headquarter building for the Dubai Emirates Electricity and Water Authority that has achieved LEED Platinum alongside complying with the Dubai Green Building Code. In Abu Dhabi, for example, the Siemens headquarters building has achieved LEED Gold alongside the Estidama Pearl 3 rating. You can see from the table in the image that UAE is listed in the top 10 building nations of LEED certified buildings, which is an excellent testament to how this region is very much conscious of the sustainability agenda, as well as the need to design and build quality stock. In terms of the Dubai municipality, one of the things I wanted to point out was how the manual, they've published a manual for green building materials. And in this manual, they speak extensively and refer extensively to the ASHRAE codes, ASHRAE 62 for material testing. They refer extensively to the CIBSE codes for commissioning, CIBSE codes for ventilation, CIBSE codes for conservation of efficiency in building fabric, and also on commissioning and management. Commissioning is a key issue here in the region, because it is recognized that commissioning is essential to completing the building and getting the full benefits, energy benefits from a building. In terms of commissioning, again, the local codes are quite scarce in its prescription of the adherence to it. So thereby, as conscious international consultants, we tend then to refer to the CIBSE commissioning codes, and we try to introduce CIBSE TM31 building logbooks and standard templates, as logs are only called for a few sustainability programs, but it's a very key document. The systems manual is extremely valuable tool in maintaining, operating, and building efficiently as possible. Locally, the importance of proper testing and commissioning of a building is well recognized. Studies shows that good commissioning can derive 20% more energy efficiency in the building that has been commissioned versus one which is not. It can derive 35% higher energy efficiency if the process has followed the LEED fundamentals commissioning system. 65% more energy efficiency if the Estidama commissioning program is followed. In terms of sustainability, we always focus on the building fabric and the thermal performance of the building envelope. The thermal performance of the building envelope is one of the main drivers in determining what the cooling load and resultant energy use will be. Hence, it is important to consider the building envelope design with primary significance, like, for example, the insulation, the U value. Facades of buildings should be configured to reduce solar heat gain and cooling energy consumption. This is particularly crucial for windows, which should be small and can be shaded well by deep reveals and external structures. This needs to be balanced with daylight and view requirements. Although in hot climates, full load conditions tend to occur more often than in temperate zones, majority of cooling coils here still operate at part load for most of their life. If systems are designed to meet the most extreme circumstances, they and their associated controls will be greatly oversized for normal conditions. Oversized air conditioning systems do not do a good job of reducing humidity. So the result can be a cool but humid environment. Also, predictably, oversized systems and waste energy. In many countries, the building codes already specify minimum building envelope performance level that are adequate. However, from the pie charts here, you can see that the biggest energy consumer is not related to the building envelope thermal performance, but rather the air conditioning systems addressing the outside air, cooling of the outside air, and the internal gains. In this instance, specifying efficient mechanical systems can end up being more important than passive design.
Okay, so there's opportunities for technology in arid climates that might not necessarily be considered in more temperate climates. One of these would be the integration of passive cooling using wind towers. It's a heat transfer device in the wind tower, and they're shown that they can reduce air temperatures on the intake by up to 12 degrees centigrade, which is significant for this region. There's also possibilities for having roof system design. So merely by changing the reflectance or the design of the roof, we can reduce the gains into the building. And one example of this is in the airport in Jordan, in Amman, the Queen Alia Airport, where there's ballasted assemblies with the drainage mat and rivered wash gravels, which creates lots of little voids for hot air to rise out, and it keeps the heat gains to the building down. Another option is for desiccant cooling. So the liquid desiccant removes water from the air and improves indoor air quality due to greater humidity control, and large desiccant cooling systems can be constructed at relatively low cost. So here are a few design watch points that should be considered when designing buildings in the GCC. For electrical design systems, the Dubai Electricity and Water Authority recommends N+1 on your main electrical infrastructure. In practice, we find that quite a few of our clients ask for N+N, so we'll have pairs of transformers sharing a two-section switchboard loaded to 50% each, and then they can take over from their neighbour if there's a failure. Typically in Europe and in the UK, we have generator backup for life safety systems and sometimes for business continuity systems. In this region, it is very normal to have generator backup for our air conditioning systems to ensure that buildings can continue to function in the warmer temperatures of the air. Space requirements are different than are asked for by the local authorities in the UK and Europe. And each authority has its own requirements. Even in the same countries such as the UAE, Dubai and Abu Dhabi have different requirements, and you need to go and discuss with the authority what they need and get the necessary approvals. The other thing that often catches people out is cooling for all electrical plant. So, and here's a typical heat dissipation for plant items. Each LV-ACB cubicle is 600 watts of heating load, or a multi-outgoing feeder cubicle is a kilowatt. Power factor correction, about 8 watts per kVAR. A 2 MVA cast resin transformer is about 23 kilowatts. And an MV panel cubicle is about 1.8 kilowatts. And that's in addition to the loads provided by the outdoor conditions.
The CIBSE and ASHRAE are very active in the region. ASHRAE in February 2014 carried out their first international conference on energy and indoor environment for hot climates here in Doha, in Qatar. With that, they covered relevant topics, from keynote presenters for the region. For example, traditional technology for modern problems like re-energizing wind towers, solar cooling in hot climates, integrating hot air, indoor air quality and energy efficiency. CIBSE globally has around 18,000 members, and like its American counterpart, ASHRAE, it is experiencing a growth spurt following an increase in construction industry activity, with numbers having risen by around 20% over the past 6 years. The bulk of its members are in the Middle East. In the Emirates, with others working in countries such as Oman, Bahrain, Qatar, and the Kingdom of Saudi Arabia. CIBSE is in the process of setting up a branch chapter here in the UAE. Meanwhile, the ASHRAE Falcon chapter, with more than 500 members consisting of engineers, architects, researchers, academicians, and technicians and students throughout Oman and the UAE. ASHRAE Falcon chapter is one of the most active chapters in ASHRAE region at large and is committed to the achievement of technical quality and excellence in all our programs, courses, and other activities. CIBSE and ASHRAE play pivotal roles in the Middle East built environment for quality construction with their standards, codes, guidance, and technical manuals. And that's the end of our presentation. Thank you very much.
Thank you for listening.
Well, thank you very much, both of you. Excellent presentation and covered a huge area of interest in the Middle East pertaining to building services, design and installation. We have a few questions coming already. Whilst we're taking questions, we can take some more questions. So if you have any questions for the two speakers, simply type it in online. You can type it in the question box, and we will pick up questions as time permits. And just a reminder, the whole presentation will be available to review afterwards in a couple of days on CIBSEASHRAE.org. So this is Tim Dwyer, chairing the webinar for the CIBSE ASHRAE Group, and let's go into our first question, a fairly general question from James, and James is asking, are air-cooled chillers considered more sustainable than water-cooled chillers, bearing in mind the scarcity of water in that part of the world?
It depends on the load, and it depends on the size of the equipment, like all things, and the consideration. A lot of water-cooled systems obviously has a high efficiency, and there's a lot of work locally to work on water-cooled system using treated TSE water, which is treated sewage effluent water. So this is part of a wider recycling system, as opposed to using fresh natural water, which is scrubbed. So if the technology is able to use and the TSE is available, it's a very sustainable system to use. Otherwise, depending on the capacity, you would always get more efficiency out of the air-cooled chillers.
Okay, well that's interesting, and we had another question from Phil asking where water comes from, as it's a precious issue. And you've spoken there of recovery of water, perhaps grey water or sewage water that's been treated. Is that the key source, or can you use deep wells for providing water for air conditioning purposes?
The primary source of water here in this part of the world, in nearly all the countries, is desalinated water. It's a highly energy inefficient system, but it is highly subsidized system as part of the development of all of these countries. So thereby, water is a precious commodity and is not highly recommended for use in air conditioning systems. So for many years there has been huge movements in harnessing TSE. TSE is short for treated sewage effluent, and where it is possible to procure TSE, depending on the district, for water-cooled chillers, then it is generally primarily used. But other than that, very few places use fresh, clean water for it.
Okay. Whilst talking about water in air conditioning, there's a question here from Kamal, who asks, what do you think about higher humidity during summer and or increasing humidity in summer, I guess, and its effect on performance of different mechanical equipment with the high climatic temperatures? So I guess he's saying, if you allow humidities to rise perhaps beyond what you might normally have in your design specs, what effect does that have?
It depends on the function and the location. Generally, most buildings do not treat humidity unless it is a sensitive environment, and that's no more so than how we treat air conditioning in the European nations, whereby you would not go into humidity control until such time as the building requires the close controls specification. So generally, humidity here is brought down by straightforward air conditioning and refrigerant, and we do allow the humidity levels to rise a little bit at the height of summer. We don't always have to bring the humidity levels right down to specification.
Okay.
Does that answer your question?
I think it gives an answer to a question anyway, so thanks for that,
Yeah.
ChewPieng. Let's have a look. Questions are flying in here, so let's have a look at something more general. We got a question here, an interesting question that I've lost his name, but we had a question here that from Abder Rahman. and he asks. He's a mechanical engineer. He's used ASHRAE standards in Middle East, and he's doing some work strangely in the UK. And he's been looking at the CIBSE codes. He's found there's conflicting requirements in the CIBSE and ASHRAE codes. Is this widely an area of challenge where the codes actually disagree with each other, or do you find generally they would concur on the main requirements?
We would always find variances, not so much contradictory. Some CIBSE codes and ASHRAE codes may not necessarily concur in its exact range of temperatures and not just the temperatures and the range of its basis of design. What I had mentioned right at the beginning was we then tend to do our own more detailed research with the meteorological data and then sometimes go to the international mechanical codes for adjudication, or else compare it against local codes and local requirements. So there is a bit of an exercise to make a more educated judgment over which code we follow at the end of the day.
I mean, that was another question I saw coming a little earlier about the plethora of codes, and what you say there, you perhaps make a judgment as to which one you should apply. So is that judgment left to the design team as to which set of standards is applied, or is it a client-led requirement, or is it in fact the municipality who will make that decision for you?
So I think it's a bit of everything. As designers, we'll make a judgment based on all the facts that we can gather, and we'll make the most appropriate judgment, and then we'll present this to the client and explain our reasons why we've decided to go down this route, and we'll then bring it to the municipality and discuss it, and if they agree, that's how we proceed. If they don't agree, we'll take on board their feedback and then review our basis of design and rediscuss with the municipality until everybody's in agreement with the correct codes and basis of design to go ahead with.
Sounds a very, very cooperative arrangement. So and quite reasonable, I would guess. In terms of applying the standards and design requirements, I've got a question here from Michael, and Michael asks, when applying standards for designs, are there opportunities for designers to use? He's actually used a term wild air, which I haven't come across, but it may be a term that's used more frequently there within designs, and allowances for phased commissioning to avoid the inefficient and expensive use of permanent and temporary plant during construction. I guess there's a requirement to ensure that the buildings are properly serviced throughout construction. So he's looking at perhaps allowing the conditions to vary somewhat more widely than would normally be the case to avoid the use of temporary plant. Is that a possibility?
I suppose anything is possible, and this is something that a client would need to buy into, bearing in mind the end users of the building. For example, if it's a high-end apartment block or a commercial building, and the rents that people pay out here for such spaces, they may not be willing to accept substandard conditions. If it's a less critical space, then that, of course, could be possible.
Okay, so again, it's a matter of negotiation with the client and the team on that. We've had a large number of questions asking about absorption chilling. It's still, we had a question actually from Jismi who says it's seen as a relatively new technology in the Middle East. His concern is that perhaps there aren't any codes that help in the proper application of absorption. And we've had other questions just asking, is absorption chilling really used in the Middle East?
No, unfortunately, not widely used because is this geothermal absorption chillers? It's not that widely used in the Middle East at all because the sizes are small. The Middle East chillers has to meet extreme, has to have equipment that are designed for the extreme climate. The absorption chillers are not widely used here at all, and there's very few codes to cover them, and the payback is not there, partly because the cost of energy here is quite low. And the energy here is using natural fuel.
I see. Yes, that puts a different complexion on it. I can see that puts a slightly different complexion on it. I guess in sustainability terms, though, there may be a case for using perhaps as we had a comment from Sadiq here. Is there an opportunity to use solar collectors with absorption in terms of sustainable design?
There is, and it is. All of these technologies are widely looked into and widely studied, but the cost of energy in nearly all of the GCC countries is quite low. The solar energy payback is attractive, but it faces the challenges of maintenance and, as I said earlier on, the issue of baked sand on the efficiencies. Solar energy with absorption chillers is very difficult to derive in its payback because absorption chillers are that much more expensive and thereby adds on to the overall and tops up the cost of the entire sustainability energy solution. So in terms of a capital cost and a long-term payback cost, it's very or never. I have not seen an installation successfully put in unless it's a study.
Okay, thank you for that. There's obviously an area of interest across a number of people, which we may see some follow-up. Kathy, you gave some interesting applications of systems to provide some reduction in load in buildings. And we've got a question here from Phil, and Phil asks, what passive design measures work in the Middle East to reduce energy consumption? So are there particular measures that are used in buildings currently?
I suppose in terms of electrical load, going for an efficient lighting solution when lighting contributes so much to the internal gains in the building in terms of heat and energy used. Getting for a commercial office, it's now possible to do a very good SLL code compliant solution for 5 watts a meter squared, and for choosing quality fittings with good quality optics, we can minimize the amount of fittings and keep the energy down. Many of the, in fact, all of the local authorities here require the loads to be submitted in connected load, not maximum demand, which we're more familiar with in Europe. And they will apply their own diversity factors there. So the more you can bring down your total connected load in a building, the less of a connection size you'll need.
Okay. Just moving on. Well, I suppose it's really moving on to the actual external climate providing reduction in load. We got a question here from Grant, just saying, do you need to make any allowance for heating during the cooler periods of the year, in particular during the mornings and evenings when the sun has gone down? Perhaps an early morning, particularly, I guess, when the outside temperatures can go quite low. And perhaps can I also add on to that? I had another question here. How effective, this is from Sadiq, how effective is night sky cooling in the Middle East, which really ties in with that requirement, which you actually need some heating. I don't know. Perhaps you could comment on that.
Again, I think it depends on the exact location. In Riyadh, the temperature can drop really quite low in the winter. I mean, this morning in Dubai, it was around 13, 14 degrees at 5:30 this morning. So whether you need to heat or not at that stage for the few hours, it's a client choice, but it's a lot of capital outlay for a very, very small time of the year. But I know in Riyadh they'll put in heating, I think, in some of the higher end hotels.
Yeah, and so in the higher specification hotels and residential areas, we may put in a small electric heater battery. It's very rare that we would put in a boiler and a LTHW system to address the heating. So to address it, we tend to, on fan coil units, have a very small heater battery if it is part of a base client prerequisite. We also work in the mountain regions in Saudi Arabia and Oman, and in those areas the temperatures go down a little bit more, and once again, depending on the quality of the building that we are designing to and the client specification, these things has been considered before.
Okay, so again, it will come down to client requirement or preference as to the systems that may be needed there.
Yeah.
Okay, thank you. Just moving on, well, to the data you use for design. I've got a question here from Iqbal, just asking. There are standards of standard weather data available in Saudi Arabia, and those standards use weather data, and his experience is that it does not match very well with ASHRAE weather data, especially the ambient conditions for HVAC. Is it difficult to actually determine the appropriate design conditions for the arid zones?
Depending on the location, if the location is in the larger city areas which are covered by ASHRAE, we would tend to use ASHRAE as a basis. But often we are designing outside of the likes of Riyadh or further into the east in Dhahran, Dammam, and in other areas where there is a temperature variance from the capital city. We would use ASHRAE as its nearest basis, but we would also go after the nearest, the Saudi meteorological data to help inform us of the variance in weather data from the CIBSE and the ASHRAE codes. So it's not all black and white. I think it's the same issue when you design anywhere else in the world. ASHRAE codes does not cover for every part of the region. ASHRAE codes are also not intuitively sensitive on an annual basis, and so as designers we would tend to also double it up with meteorological data.
Okay, so you'd have to do some sort of micro or mesoclimate survey for that to really pin down your requirements in a particular installation. Interesting question here, and I because of energy tariffing in the rest of the world, thermal storage is very very common across the world in various formats. And I've got a question here from Anne, who asks, is ice thermal storage used at all in that region?
Yeah, yes, it is, but often not for the cost-saving issue, but in areas where there's limited infrastructure capacity to assist with peak load lopping, we'll use ice thermal storage to minimize our electrical connection size.
Ah, yes, of course. And have there been many installations of that, Kathy?
We've installed ice thermal storage in one of the most significant buildings, iconic significant buildings in Riyadh, for example. But subsequent to that, there hasn't been much more installed, because at the time when that building was being designed, the electricity network was in the throes of being upgraded. and thereby we address the problem with the lack of the infrastructure with the ice thermal storage solution for the peak load lopping. Subsequent to that, the area has become more developed, the infrastructure has become more robust, and thereby the payback of the ice thermal storage has not warranted any further building stock putting it in. Having said that, we work further afield into other developing nations like Azerbaijan, and we have recently been looking into them for some of their ice thermal storage for their iconic buildings. At the end of the day, the ice thermal storage as a system, in terms comparative to the low cost of energy here, is quite difficult to balance off in terms of its capital payback. Also, the complexity of the controls and complexity of the systems can cause operational issues further down the line. It's not something we would generally try to recommend unless the infrastructure suffers from peak load issues.
Or if there's a requirement from the client side to have like 100% backup system, and then to reduce the amount of installed generator capacity, we can look at backing up the chillers using the ice thermal storage.
Okay, well, thank you for that. We've just got a couple more. We can fit in a couple more very, very swift questions. There's loads coming through, but let's just take one here. We haven't touched this area at all. What's the testing regime recommended for air infiltration of facades or buildings? The comment being that there is the build quality can really be an issue in many occurrences.
Yeah. A lot of this part of the world not suffered, but went through a huge curve of development in the in the early 90s to mid 1990s. And so there's huge stock of buildings whereby the facades has not been of the best quality, and yes, you do hear frequently of the poor quality of the installation and air leakage and everything. But with the financial downturn in the last few years, buildings that are coming up has had more. There's been more control over what is being put up. There is much more consciousness over quality. There is less of a rush to put it up tomorrow, and thereby the market is now has got more opportunities and more people out there who will do building air leakage testing. Clients are also much more aware from past lessons learned that facades has to be tested, has to be properly installed, time has to be given for them to be brought in, and quality facades is being put up. So this is all work in progress, and we're quite positive that the next stock of buildings will be much more robust than the boom days.
Okay, so it sounds like the buildings are getting better, and there are people out there who are doing air tightness testing as well. So there are methods in place. So my final question, and this question I'm sure we could have a whole webinar on. This is a question from Phil. Phil's asked a few questions today, and his question is: how is future climate change being accounted for in terms of adaptation and resilience? Is there anything is there a one line or a two line you can give the audience on that?
I suppose I think that the fact that Qatar and Abu Dhabi and Dubai have all implemented their own sustainable guidance and rating systems means they're aware of something that they need to consider and that they're taking very seriously.
Okay, and in terms of design, are you taking account of expected increase in temperatures or changes in solar irradiance in the life of buildings?
I think in that instance, whereby, as I alluded in my presentation, with such extreme climates, a lot of the building services systems tends to be over-designed because we have to meet peak performances during the summer, and it does happen quite a peak performances does exceed published figures at the moment. If we were to design for the ASHRAE codes for the 10-year and the 25 years, equipment will be even further over-designed. And as designers, we have to be cautious of that. We have to be cautious that, you know, buildings and equipment has a lifespan which is probably less than what the anticipated future climate change is going to cause us. So we have to be careful not to over-design all our systems.
Okay, well, thank you for that. That's a good place to finish, as we've seen many systems in the past that have been over-designed and are totally uncontrollable, or their life is actually shortened because of it. So thank you for that. We're a little bit over time, so just briefly to say thank you to both our speakers who put a huge amount of work in today's presentation. It's been an excellent presentation, really wide-ranging. Both ChewPieng Ryan and Kathy Elliott-Scott from Bureau Happold. And thank you, of course, for everybody for joining us. It's been a fantastic response to this webinar. And one of the questions that came in was actually saying, is it possible to hold a workshop actually locally in the Middle East to discuss some of these areas, a forum? Well, I know that there's areas, these sort of questions are covered both by the local CIBSE region in the Middle East, and also by the ASHRAE Falcon chapter. They hold regular meetings, and other Middle Eastern ASHRAE chapters hold regular meetings where you can go and discuss the sort of points that both Kathy and ChewPieng raised today. So thank you, Kathy. Thank you, ChewPieng. Excellent presentations. Thank you, everybody, for joining us. It's been a great session.